And now we've been shipping GB200s a year and a half ago. Right now we're in full-scale manufacturing of GB300. And if Vera Rubin is going to be in time for this year, it must be in production by now. And so today I can tell you that Vera Rubin is in full production. Model, we scaled it up from DeepSeek, that's why we call it DeepSeek++. And today we're announcing that Siemens is also doing the same thing. We're going to integrate CUDA-X, physical AI, agentic AI, Nemo, Nemotron, deeply integrated into the world of Siemens. And the reason for that is this. First, we designed the chips, and all of it in the future will be accelerated by Nvidia. You're going to be very happy about that. Second application I'm going to talk about in just a second. This is a revolutionary processor, and I'm so excited about it. This is the transformer engine inside our chip is not just a 4-bit floating point number somehow that we put into the data path. It is an entire processor, a processing unit that understands how to dynamically, adaptively adjust its precision and structure to deal with different levels of the transformer so that you can achieve higher throughput wherever it's possible to lose precision and to go back to the highest possible precision wherever you need to. That ability to dynamically do that, you can't do this in software because obviously it's just running too fast. And so you have to be able to do it adaptively inside the processor. That's what an NVFP4 is. When somebody says FP4 or FP8, it almost means nothing to us. And the reason for that is because it's the tensor core structure and all of the algorithms that makes it work. NVFP4, we've published papers on this already. The precision, the level of throughput and precision it's able to retain is completely incredible. This is groundbreaking work. I would not be surprised if the industry would like us to make this format and this structure an industry standard in the future. This is completely revolutionary. This is how we were able to deliver such a gigantic step up in performance, even though we only have 1.6 times the number of transistors. Switch. The reason why this is so important, and we've made enormous progress. Today we're announcing Alpamayo, the world's first thinking, reasoning, autonomous vehicle AI. Alpamayo is trained end to end, literally from camera in to actuation out. And innovation across every single company and every industry around the world is activated. The model here is called Alpamayo. And Alpamayo today is open sourced. This incredible body of work, it took several thousand people. Our AV team is several thousand people, just to put in perspective. Our partner, Ola, I think Ola is here in the audience somewhere, Mercedes, agreed to partner with us 5 years ago to go make all of this possible. We imagine that someday 1 billion cars on the road will all be autonomous. You could either have it be a robo-taxi that you're orchestrating and renting from somebody, or you could own it and it's driving by itself. Or you could decide to drive for yourself. So this entire stack is our first NVIDIA entire stack endeavor, the work that we've been doing in self-driving cars. Not only do we open source the models, we also open source the data that we use to train those models. Because only in that way can you truly trust how the models came to be. We open source all the models. We help you make derivatives from them. We have a whole suite of libraries. We call the NEMO libraries, physics NEMO libraries, and the Clara NEMO libraries, each Bio NEMO libraries. Each one of these libraries are life cycle management systems of AIs. The work that we did in proteins, in digital biology, La Proteina, to be able to synthesize. And obviously, if you have a long conversation with that AI, over time, that memory, that context memory is going to grow tremendously. Not to mention the models are growing, the number of turns that we're using the AIs are increasing. We would like to have this AI stay with us our entire life and remember every single conversation we've ever had with it, right? Every single lick of research that I've asked it for. Of course, with the number of people that will be sharing the supercomputer is going to continue to grow. And so this context memory, which started out fitting inside an HBM, is no longer large enough. time is the same for everybody. Now, how fast you can train that model and how large of a model you can.